Hello, this is the last session of model question paper solution. We have reached the last part of the question. Explain the p-thread create by calling it with a sample parameter, not with yeah, sample with sample parameters, and explain the role of each parameters passed to it. So the answer is here, not the answer, entire answer, because you have at least you know what is the thing, but there are two things which are null. Unless you know what they are, it's difficult for you to answer the question, right? Now let us look at it quickly. Pthread create ampersand id. Okay, what is this? We'll see. This is some star attribute. Okay, and then thread function, then an argument. Okay, this is how you call. Now what is this type? This is an attribute type. Okay, which you can look at the code of our lab implementation, wherein we have a specific attribute to be passed to the thread create function. Okay, so what is this second parameter? So let us look at the details of those parameters. This is the lab 7. This function has been well explained. So the first parameter is pthread of t. Okay, you have to mention the type of the first parameter pointed to a pthread t. That underscore t is a type of pthread type. So it is actually passing a pointer to pthread create. While creating it a new thread, it has to write back the thread id that it has created, and then we are saying const pthread attribute underscore attribute. So this is a pointer to an attribute structure which is defined by the pthread library for you to configure specific values in this attribute and then pass it to the function. So when you want to create a thread, you want to create it with some attributes. Okay, what is to be the stack size, what the type of priorities you want to give it, lot of many things you can actually give it as a part of the attribute, because we are not giving any other attribute other than the start routine, which is a thread function, and then argument to it. Other than that, about the thread we are not actually giving any attributes. Okay, that can be given here, but we are not actually going into the details of that. But when you want to develop some application, you can actually go deeper into it and then analyze it and then give specific attributes so that you can create threads of different priorities based on your application. So that's the purpose of providing this particular thing. This is an input to the function. Remember, this is not this is filled by you and then used by the thread library. And then what is void star? This is the typical function pointer, which is start routine. It's a function pointer which accepts a void star and returns a void star. So this is the thread function, which this is exactly a prototype of this particular library. And then it returns an integer to mention about whether the status is okay or not, whether it is successfully created or not. Minus value means not created successfully, otherwise it is yes. Now void star argument is an argument to be passed to this function. So you are giving the function pointer separately, which accepts a void star. That means you have to provide the attribute also, the parameter also. So when this pthread create is successfully created, it is going to call this function with this argument which you have passed to it, because it doesn't know what to give as an input to it. Okay, as a user, as an application developer, you know what your thread function should be given as an input. So these are the explanation. It can be passed some attributes. Second parameter, third entry is a function pointer, thread entry, and void star is a parameter to the thread entry function. So this is what you are supposed to do when this question 19 is asked for. Okay, that's what is the question 19 is expecting you to do. Now let us come to question 20. It's very easy because I have already explained about what is fork, and we have a detailed discussion about that some time back. So if you have gone through the earlier videos, and this is going to be a breeze. Now question 20. Now when the following code is executes, what will be printed? You can assume that always the parent process gets a chance to run before the child processes get a chance. Okay, after any fork call. Now Actually, does it matter or not? It doesn't matter because there is only one printf is there in this particular code. So you can actually, even without this assumption, you whatever printout you are giving, output you are giving, it will be okay. Now, if you find that it is maybe giving tens of 11 printf functions, this print is going to be printed so many times. I don't expect you to write this so many times. Okay, what appears on the screen, that is like an imposition in the school days what you have done. So you can actually say that this at the end of the four calls. Okay, carriage return, don't give it as a slash n, because when you print it, slash n will not be coming on the screen. It will go to the next line, right? So it's a carriage return. So what you can do is this particular line excluding the slash n will be printed so many times. Okay, that is what you are expected to do. But in case if there are some different messages are given and some questions are coming with variable number of printfs, then you have to mention what will be which message or which printf messages or things will be coming and how many will be printed, something like that. Okay, now look at this code. It is the first instruction which is given. Okay, assuming that include files are all done properly. Now this will be printed once, right? And then fork call happens. So when fork call happens, it's actually not changing anything. No changes are happening to the code. So there is only going to be a single image of this question 20. Okay, if it is a question 20.c or something, there's going to be one image on the main memory. Okay, code area, as well as data is also not being shared, and stack may be separate, but still it is actually keep calling this fork function, system calls, and then goes in. Now, what happens in fork? We saw the previous question there somewhere that it returns something, but we are ignoring it here. What is being returned is ignored here. Then what happens? It is returning two different values, but you are not reading both of them. So the behavior of both parent and the child, which is waking up from this function, is going to be the same. That is, it is going to execute the next line. Okay, there is no if condition, else condition, so you don't need to worry about that. So it is going to execute the same thing. Now, how many will be executing? That is the beauty. Now, initially, first one message will come, one parent is coming in, that this message of whatever is there in sort of model question 20 will be printed only once, and then fork is called. Now, beyond this fork, there is going to be two execution coming, and then second fork is there. Let me write all the forks. Four forks are there. Now, this also will execute the fork. This also will execute the fork. Remember that this fork is one, but two times it is going to be executed because it is returning twice, and both are coming below to execute the remaining instruction, because it's not going to change the code or something, but it's not modifying anything. It keeps reading the instructions and executing it. So it will be two processes will be executing it. Now, when this fork is done, again it is going to create this parent. This is a P. This will continue as a P. Now this was a child here, but that will be again, I will say C1. C1 will come here. C2 will be there. Now let me call this, one more will come. Let me call this as C3. Okay, we can give some number, right? Unique number you want to give. Now this fork comes. What happens? This also is going to be, this P will be there. Okay, and then, okay, let me give it like this. Then one C3 was there, so C4 will be here. Now this guy is going to again fork into 2, and C3 will be remaining. It is going to create one more. Okay, C4 is here, so C5 will be created. Then similarly this 2 and this 2. Then one more is there, then 2. So that means every level is going to be by 2 to the power something. So this is 2 to the power 1. These two processes are created. This is 2 to the power 3. Okay, I'm sorry. This is 2 to the power 0 because new process is not created. One parent is there and then one child. Okay, every fork one new gets added. The problem with the second fork is it is executed twice. So it will look like this fork is generating two more. but actually it's generating only one new process. Every fork is creating one new process only. Because it is executed twice, at this level it is going to be 2 to the power 2, this is going to be 2 to the power 3, and this will be 2 to the power 4. Okay, this is very simple. It's a river binary tree actually. Okay, you will have like this, you will have, they based on the levels. Okay, you will have this and this is okay. So the totally there will be 16 processes will be there. Now let us look at one code which the same code written there. Four forks are there, and then at the end of the all four calls. Okay, and just to see how many processes are there, I have put a while one which is not shown there. Doesn't matter because we want to know what is being done, and this while one will help us whether our assumption is correct or wrong. So this is a question 20 model. So let me compile it and run it. GCC minus, okay, let us see what is the file name. GCC minus O output Q20 model C. I'm sorry, this is input file. Output should be Q, maybe some short name I given. Now Q20. Oh, many things are happening. Now it is waiting. Okay, now let us go to the other window and then check whether, oh, I am here. So anywhere, I can be anywhere. Okay, doesn't matter because I am interested in knowing how many Q20s are there. You see now the same Q20 program is executed by multiple processes. So from 1, 3, 0, 7, 8, 9, 10, 11, 12, all sequential numbers are given up to 22. How many are there? 16 are there. You can count it, freeze it and count. 16 will be there. So 16 processes have been created in that small 4-line code. Okay, so let us now stop this thing. What happens is one control C signal, since all the processes created here are all tied to this particular terminal, all of them are given the control C. So when you say one control C, it means that you want to terminate all these processes. So all the processes get killed. So if I say PS all, nothing, all Q20 has gone. Okay, this is what happens when you run this program. I hope this explanation is enough to understand this code, and I expect you to run this piece of code and execute it and check it once, and put a while one like what I have done, and then make sure that you count the number of things. Otherwise you will not even know how many got created. Okay, and you can even plug in some printf somewhere and then see how many will be printed and what is the behavior, how many times each fork is executed. This is the understanding that you need to have. Okay, now we are moving to question 21. Okay, we'll quickly be completing it now. Okay, this is very simple as I have explained it in detail about pthread create and what is doing. What I expect you to do is not to say that pthread create is called with id and null and thread function as a parameter. If you write like this, it actually proves that you know how to read English. You know that parentheses are like parameters, and values id null, these are all first and second parameter. You know that these are the parameters and getting passed to the certificate. But that is not what is expected of you when explain this source code. Okay, when you have to explain, you have to explain what is happening in the background and not what is written on the line. Okay, that anyway anybody can read it, right? Pthread join is called twice, and then printf I am here is printed after the through thread join. It's not an explanation at all. It proves that you know how to read a code. Okay, actually what is required is to explain that pthread create is called to create a thread which will run in the context of this process, which is this executable main thread, and the same thread function is given for both the threads, and because it is calling two threads, and they will be executing the same thread function. Now attribute is not given, and default attribute will be taken. It will be the thread will be created with the default attributes, and there is no parameter passed. So this thread function doesn't expect a parameter, but actually it has. Okay, what happens is null is passed here. Now by any chance, okay, by any chance, Even you can try it out in the same code if you have patience to write it out, or whatever code is there in the lab you can change it. If you pass a null here and then anyway you have to say args here, but if you try to access args, suppose printf percentage s slash comma arg. Now what happens is you are trying to print the parameter which is passed to this thread function, which happens to be a null. So it will terminate. Now it will be your program will be terminated because you are trying to access a null pointer. Now accessing a null pointer is not allowed. Okay, this is different from a string terminated with a null character. That is a valid one. That is to know that the thread your string has ended. A null value is different from a null pointer. Null pointer means you are trying to access the address 0, which is not a valid address as far as I told you many times. So accessing a null pointer is wrong, whereas string terminated with a null is required for your string manipulation, so that you know that where the string is ending. Okay, so here you have to be careful that you don't try to access the arg, but arg has to be given because that is the expected of it, because you have to say that this thread function when you are defined it is accepting a void star. But the problem is when this thread function is invoked after the thread create, it is going to call the thread function with the parameter what you have passed here, because if you have passed a valid string address or something, then you can print it, but you are passing a null, so you better keep quiet that okay, I know that there is no parameter coming, so don't access it. So that's what I have done. I said thread is created and I slept for 2 seconds. So you have mentioned that the thread is printing this thread is created, each thread will be printing it, and then it will sleep for 2 seconds. So that seconds is important. It will sleep for 2, doesn't mean whether 2 minutes or 2 seconds or 2 milliseconds. So mention that 2 seconds and then say it will print I am going to exit after waking up after 2 seconds, and it is exiting using null. Now because pthread exit is called and this thread result it is passing a null, so thread result will be getting a null value. So you should not try to access the thread. Maybe you can mention that as a one of the caution, because imagine that you are a senior person in a company and then some junior is joining your company and then you are explaining this code to that person. What are the things you would tell? That's what I expect you to explain in the exam. So make it short, don't have to be 4-page write up, but to the point and bring out the key points. Okay, here thread exit is pass a null, so that is going to be written into the thread result pointer. So you never try to print the thread result here. That's a caution you have to take. Similarly, this you are passing a null, so arg is going to be getting a null value, so never try to print it inside of that function. That's it. I think because you are calling pthread exit, both the threads are going in pthread exit, pthread join will be successful, and I am here will be printed, and it will get into a permanent loop, infinite loop, wherein this program will run forever. So main thread will run forever, and thread 1, thread 2 will be terminated after 2 seconds. That's what is the summary of the discussion on question 21. Now, final question, last question, it's a script. So remember that you don't have to compile this, and this is a script file, and which script is shell is calling, it's a bash. And where is it there? It is in the /bin directory. Maybe you can go to cd/bin. I'll show you. Maybe cd/bin. I go there. Okay. Now ls -l. Okay. Bash start. So this is the thing which is getting executed, and you can see that all the user owner is this root owner, I think root owner, yeah, as well as group, all the users of this system, others also will all be given executable permission and read permission. See, now write permission is given only to the root, so bash you cannot modify it. But actually it's a executable. It's a green color shows that it's executable because x is there, and this is what is getting executed. Now it is calling this function bash executable, and then what is it doing? It is going to pass this whole file as an input. Okay, this is shebang, and it is going to pass this whole script file to it. So bash only understands this shell script. Now what is the shell script? It already says that it is going to print parameter 2 numbers. Okay, starting from parameter 1. That means suppose if I am passing 5 as a parameter 1 and 3 as a parameter 2, what happens? So let us understand that. Okay, I am writing /Q22 dot sh, okay, and 5 3, okay, carriage return. Now what happens, I want to start from 5 and I want to print 6 7. That's three pair numbers starting from this. Now this is it happening here? So it will be printing starting number is passed is 5 and the number sequence passed is 3 3 numbers starting from the number, and then sequence is not greater than 0. Oh, sorry, yeah, sorry, it's greater than 0. GT is greater than 0 till it becomes 0. I want this to be in the while loop, so echo the number 5. Okay, 5 will come out on the screen. Then that 5, this dollar starting number means you are accessing the uh, number being passed in this variable start, no, this label. Okay, we are writing $1. This is the first parameter which came argument which came in is written into it. Second argument is here, so it is incremented. So 5 will become 6 and sequence 3 will become 2. Then it goes again, 2 is greater than 0, so 6 will be printed, and 6 will become 7 and 2 will become 1, and it comes here. 1 is still greater than 0, so 7 will be printed. Now 7 will become 8 and 1 will become 0. Now when 0 is not greater than 0, it come out. So 8 will not be printed, though the last, if suppose if I come out of the while loop, if I have to know the value of if I write it like this, value of starting number, maybe that will be a good question to ask. At the end of this, I put a echo and then tell you what is the number being printed, then you should say that it is 8. Okay, because it would have got incremented, but num sequence would have become 0. Okay, that's all is the sequence shell script. I want you to understand basically what is the shell script and how it is running. It should have executable permission and it is picking up the bash, and that is what we are giving it as a first shebang. That's all. I'm sure this all these videos, if you have come up to this particular video, I thank your perseverance, and I'm sure if you have understood all the things so far explained, it will certainly be enough for you to have a clarity and you can be confident because you have understood everything, and you should be able to not only write this midterm exam, always you will have a very good understanding of OS, as well as it will help you now whatever you write, remember it, because it is required for you to carry on this knowledge for completing the remaining labs and OS course. Okay, all the very best and take care. See you in the next whatever possible opportunity to talk to you in the class as well as in the video, through the video. Bye bye.